Next, one important part is there, that is Kendall's notation for queuing models. So we generally note the queuing model by using one notation. That notation is called Kendall's notation. You see here A in this notation, this is general notation. A within one parenthesis, A front slash B front slash C, these are all places where we shall define some components. Colon D front slash E, here also we shall define some components. Here this first place goes to probability law of arrival or inter arrival time. Probability law of arrival or inter arrival time. And the second place B occupies probability law according to which the customers are being served. So this is arrival pattern. Here A explains you arrival pattern and B tells you about service pattern, and C is nothing but number of servers. In ATM kiosk center, if 3 ATM machines are there, then C equal to 3. In any banking section, if number of cashiers are 2, then like that. And next, colon, this D front slash E, D defines the maximum number of persons, allowed in the system, in the service or waiting, as well as waiting. Number of person in some, let us consider ATM machine center. One person is getting money from ATM machine, then another person should wait outside. So there number of person allowed in the system is restricted. And next E, this E is nothing but queue discipline. This queue discipline, what we have seen, that FIFO model, whether this is FIFO model or LIFO model or CSIRO model or PIR model. But generally we are going to see solving problem as per our syllabus. In this section we see FIFO model. And the above notations, these notations are called Kendall's notation. This notation is very important, and as well as important university questions also for a small mark question. And next, the 4 important models are, first one M1, I mean M front slash 1 colon infinity bar FIFO. Here that M defines Markovian model or Markovian process, Markovian model. Under Markovian or Poisson model. Markovian model is based on Poisson model, I mean Poisson process only. That M, first M is arrival pattern. First M defines arrival pattern. Second M defines service pattern. And last, this one is nothing but, as per the construction of the formula, what is this one? Number of service station. So here number of service station is 1, and this infinity place goes to D. This D is nothing but maximum number allowed in the system. So here infinite number of persons or infinite number of customers can be allowed in the system. And the queue discipline, this place is nothing but queue discipline. Here we are going to see all problems under FIFO model, I mean first in first out model. Okay, and always you should note one thing, arrival pattern follows Poisson process, and the service time distribution or service pattern follows exponential distribution. Okay, note this important point as per the law of queuing theory. Next, these are all some important notations and terminologies. First, these are all notations. These notations, queue size or line length can be denoted by N. This N defines number of customers in the system. And this Sn defines the state in which there are N customers in the system. So Sn defines you N number of customers in the system. Next, Pn. This Pn is nothing but steady state probability of having N customers in the system. Pn is steady state probability of having n customers in the system. Note this point. And Pn of t, transient state probability that exactly n customers with respect to time t. So at time t, that is Pn of t. And lambda as usual mean arrival rate that follows Poisson pattern. And lambda n mean arrival rate when there are n number of customers in the system, that also follows Poisson pattern as it is arrival rate. So lambda, you have to keep this in mind. Lambda always defines arrival rate. If arrival rate is given, then we have to take that rate, that amount is to be lambda. And next one, this mu, you see this mu is nothing but service rate or mean service rate, otherwise average service rate. This mean service rate always follows exponential distribution. Mean service rate follows exponential distribution or exponential pattern. Next, mu1 is nothing but mean service rate when there are n customers in the system. What is system? System is nothing but number of customers are there, whether they are waiting, they should follow one queue, or they can be allowed to wait in a waiting hall, and one server is there separately, and whether they allow one by one or not, or whether they are being chosen priority in random selection, like that. So this entire number of customers and servers, waiting hall, this entire pattern is called one system. Okay, here mu n is nothing but mean service rate when there are n customers in the system. And ls is nothing but, these are all important notation. You should note that this ls, lq, ws, wq are all important notations. Okay, ls is nothing but expected or average number of customers in the system. So in the system, this s defines it is system. So L defines number of customers. So ls is nothing but number of customers in the system, and lq is number of customers in the queue. So L defines number of customers, and this s defines system, and q defines queue. So ls is number of customers in the system, lq is number of customers in the queue, ws is waiting time of a customer in the system, and wq is waiting time, expected waiting time of a customer in the queue.